Good morning, everyone. I hope everyone is safe and sound in this life-threatening COVID-19 situation. I am here to present our manuscript titled A New Ensemble Model for Phishing Detection Based on Hybrid Cumulative Feature Selection. I am Asif Hassan, co-author of this manuscript, presenting in front of you on behalf of MD Shirajum Munir Prince, who couldn't present because of illness. Last author of our paper is Faisal Muhammad Shah. We all come from Ahsanullah University of Science and Technology, Dhaka, Bangladesh. A new ensemble model for phishing detection based on hybrid cumulative feature selection proposes a model that partitions the main dataset into n partitions based on the feature available in the dataset. This process is done by feeding the dataset into multiple feature selection methods: chi-square, gain ratio, information gain, Pearson correlation coefficient, in short PCC, and principal components analysis, in short PCA. Arranging the dataset into n datasets, taking top n features including the class level given by the filter method and discarding the remaining ones each time. Then each partitions of the dataset are used for training and testing using 5-fold cross-validation, applying a number of classifiers: support vector machine, in short SVM, naive Bayes, C4.5, random forest, in short RF, JRIP, part, and k nearest neighbors, in short KNN. In the next, the results are voted to get the best possible result. Web phishing is one of many security threats to web services on the internet. Web phishing aims to steal private information such as usernames, passwords, and credit card details by way of impersonating the legitimate entity. This paper mainly focuses on applying a machine learning framework to detect phishing websites. Rather than using a single approach to select feature subsets as the previous methods do, hybrid methods combine the different approaches to get the best possible feature subset. The idea of ensemble classification is to learn not just one classifier but a set of classifiers called an ensemble of classifiers, and then to combine their predictions for the classification of unseen instances using some form of voting. In short, description of the workflow diagram is described in this state. Identifying phishing. To construct an ensemble method is the primary task, where phishing dataset is set forth as input. To find out the most effective feature set, feature selection techniques are operated on dataset. Sequentially, the feature subsets are run through classification algorithms to evaluate the performance of a particular feature subset. Finally, to accomplish the final outcome, the aftermath is pooled using majority voting. A brief description of the proposed model is described next. The flowchart of the whole model is depicted in this figure. The phases are indicated as phase 1 and phase 2. In this phase, the sequence of the most important features of phishing dataset are selected, and based on that, top n feature subsets are selected. Then, using the top n features and the class level, the dataset is partitioned into n sub-datasets. For selecting the top n features, we have used 5 feature selection methods so that we can have a general idea about the most relevant features from the dataset. To extend further, let's say the dataset is supplied to chi-square to get the features ranked according to their relevance. Then we have removed all the features except for the top 1 feature and the class level and created a sub-dataset which we call FS11. For FS12, top 2 features and class level both are kept, removing the other features from the dataset to create feature subset 2. Finally, full feature sets are taken and stored in different dataset named FS1N. For other filter methods, gain ratio, information gain, PCC, and principal component analysis, PCA, accordingly. In this phase, all the feature subsets are fed into the classifiers. Feature subsets trained and tested using 5-fold cross-validation model to obtain the accuracy of each feature subsets for a particular filter method. The above training and testing continued to calculate individual performance. As far as voted results are concerned, majority voting is applied after classification to get the most probable outcome for top 1 feature subsets from all the filter methods. For the proposed full feature set model, the dataset is given to the voting mechanism to vote in the Excel result from the classifiers. This voting applied twice for the reduced feature sets and the dataset containing all the features to get a contradiction about the performance of these complex models. A voting ensemble is an ensemble machine learning model that combines the predictions from multiple other models. It is a technique that may use to improve model performance, ideally achieving better performance than any single model used in the ensemble. Every model makes a prediction for each test instance, and the final outcome prediction is the one that receives more than half of the votes. If none of the predictions get more than half of the votes, the ensemble method could not make a stable prediction for this instance. Although this is a widely used technique, the most voted prediction as the final prediction. In some articles, this method being called plurality voting. For this particular research, we have used phishing dataset for machine learning feature evaluation. This dataset contains 48 features that were evaluated from 10,000 phishing web pages and legitimate web pages. In terms of quantity, both the categories are same as each other. There is no missing attribute. Fish Tank and OpenFish are the phishing web page sources, and Alexa and Common Crawl are the legitimate web page sources. Left figure shows a clear visualization of the performance comparison of the classifiers that were evaluated using the feature sets filtered through chi-square. In this case, random forest is found the best, scoring an accuracy of 98.36%, and naive Bayes is the worst among all the classifiers. Performance comparison of the classifiers based on feature subsets filtered by information gain is given in the right figure. Random forest again hit the highest accuracy among all the classifiers, and so does naive Bayes, which is the least accurate one. This time the accuracy is 98.36%. Left figure depicts the differences in accuracy based on the performance of the classifiers. This time feature subsets from gain ratio are used to examine the classifiers. Like chi-square, random forest is the outperformer with 98.27% of accuracy. Right figure announces the top-notch performance by random forest for principal component analysis feature subsets with an accuracy of 95.79% for the top 33rd feature set. It is to be noted that PCA reduced the 48 features to 35. Unlike in the other models, K nearest neighbors here is a good competitor for random forest classifier, scoring almost same till the 20th feature subset. 98.33% is the accuracy of random forest, which still is unbeaten even for Pearson correlation coefficient feature subsets. All the information is shown in the left figure. Though it was not quite possible to detect the best performer for the other models in the early stages, in this particular model it is even more impossible to determine the best feature subset until the 8th subsets. Right figure is the graph comparison of random forest classifier for all the feature selection techniques. Since random forest is one that topped the result each and every time, performance of the classifier is brought to a disparity to evaluate the best performing feature selection random forest duo. It is from the figure that information gain combined with the classifier is one that climbs to the top the chart, scoring 98.36%, leaving behind the other models. Right figure shows the ROC curve of the proposed model. A ROC curve is drawn to determine how accurate the model performs. Abbreviated as receiver operating characteristics is the widespread and the most prominent method to illustrate the performance of any model for any classifier that has binary class level. This graph is drawn by plotting false positive rate to the x-axis, true positive rate to the y-axis. The closer the graph to 1, the better the model. Table shows the comparative statistical performance of the classifiers on the minimum feature sets and the full feature sets to achieve the highest accuracy. It is clearly visible that in every scenario, random forest has the best accuracy of 98.36% for top 32 feature set, while the proposed model scores 98.24%. Average runtime of the model is sorted in table. Though the proposed model takes much more time than all the other models, when it comes to the performance, it performs more accurate than the others. On the contrary, gain ratio takes the least time to build the trained model, taking 1.85 seconds. A performance comparison between the different research works that we have studied and the proposed ensemble model is given in this table. This benchmark shows that our model outperforms the models. Though our proposed model could not reduce feature in a significant number, still it could perform to that extent to cross the works that are much more efficient in reducing the number of the features. Based on the works that have been done so far, another looks at the reduction to a baseline feature set would be worth of time. In the future, we would like to work on filtering the minimum number of features that can perform as well as the full feature set, so that the model can produce more accurate results in less time. Though calculation time mostly depends on the machine that is used to perform the analysis, still lesser production time with lesser complexity would be a good evaluation of any model. We have a wish to work on a real-time database. This is some key performance of our presentation. Thank you. If you have any question, please write down in the comment. We will answer it in future. Thanks for your patience.